Hi everyone, today we're going to be learning about how a radio FM receiver circuit works. So first of all, let's start by having a look at its circuit diagram. Okay, this got a bit too complex. It's better we understand this through a simpler block diagram. Wow, this seems a lot better. Now let's go on and understand these components part by part. Now moving on to the radio components, let's study about the antenna first. In an FM radio receiver, it is the antenna which intercepts radio waves and converts them to tiny alternating currents which are applied to the receiver. The receiver then further extracts the desired information. Radio waves are electromagnetic waves generated by a radiating element called transmitting antenna and absorbed by receiving antenna.
RF filter filters out the required frequencies from the frequencies received by the antenna.
Next, we have the RF amplifier. After going through the antenna, the signal then reaches the RF amplifier. The tuned RF stage with optional RF amplifier provides some initial selectivity. It is necessary to suppress the image frequency and may also serve to prevent strong out of passband signals from saturating the initial amplifier. An image frequency is an undesired input frequency equal to the station frequency plus twice the intermediate frequency. The image frequency results in two stations being received at the same time. After the RF amplifier, the signal then passes on to the local oscillator. A local oscillator is basically an electronic oscillator used with a mixer to change the frequency of a signal. It is usually a variable frequency oscillator which is used to tune the receiver to different stations. This frequency conversion process, also called heterodyning, produces the sum and difference frequencies from the frequency of the local oscillator and the frequency of the input signal. This is the component of a receiver that helps us to select desired station. After that, the partially filtered signal passes through the mixer. The mixer changes the incoming radio frequency signal to a higher or lower fixed intermediate frequency. An intermediate frequency is a frequency to which a carrier wave is shifted as an intermediate step in transmission or reception. This is created by mixing the carrier signal with the local oscillator. After the mixer does its work, the signal passes on to the IF filter. As the name suggests, IF filter is used to filter the intermediate frequencies. The choice of the type of filter will depend upon the particular radio receiver design, its requirements including performance, cost, frequency of operation. These days, LC filters are not widely used because the cost of winding coils is high, and often ceramic filters are more convenient, cheaper, and offer a better level of performance. After all these processes, the signal gets weak. For this, an IF amplifier is used to amplify the signal. The signal is then passed into a demodulator. Demodulation is basically extracting the original information bearing signal from a modulated carrier wave. A demodulator is used to recover the information content from the modulated carrier wave. It extracts the audio or other modulation from the IF radio frequency. The extracted signal is amplified by the audio amplifier and is then fed into a speaker.
In this circuit, the signal we get from the antenna goes into the mixer. The mixer in this case is the BJT TR1. Now we also have our local oscillator, which is made up of the inductor L1 and the two variable capacitors in parallel VC1 and VC2. VC1 has a large capacitance and VC2 has a small capacitance. For tuning, we use VC2 since it has a smaller capacitance for the rough tuning, and VC1 which has a larger capacitance for fine tuning the network. Now the signal that we get from the antenna and the signal from the local oscillator both go into the mixer and get mixed into a sum and difference of both the signals. From there on, the signal goes into the intermediate frequency amplifier and filter, which in this case we've got three intermediate IF filters and amplifiers connected in series. C3, R3 and TR2 make up the first pair of filter and amplifier. C4, R5 and TR3 the same way make up the second filter, and C5, R7 and TR4 the third filter. So what the filter does is it allows only one particular frequency to pass through, say 150 megahertz. So the signal that we get from the antenna, not necessary that the desired signal we need is at a particular frequency, say again 150 megahertz. So what we do is we take the signal from the local oscillator and pass it through the mixer along with the signal from the antenna, so that the required signal that we need becomes 150 megahertz. So on passing this mixed signal through all three filters subsequently, slowly removes all other frequencies which act as noise in our case, and finally what we have is the signal that we require at 150 megahertz, which is then decoded and sent into the headphone.
Now the next question arises is that how does the radio know that it has to operate on 93.5 FM and not on 92.7 FM? So the answer is that in order to listen to 93.5 FM, we change the frequency of the LO such that the sum of the frequency of pass filter and LO is equal to 93.5 FM. The mechanism of LO has been explained earlier in this video.